It's officially time to get working on the fuel system. On these engines, fuel system is extremely critical. It has to be right. There's a lot of things that you can do, can't do, got to do it right. So I have been in contact with a number of people. I've heard different stories and differing techniques on how to handle it. The factory fuel pressure system has a variable speed pump in the tank. That pump is controlled by a fuel pressure control module that talks to the ECM from the engine. The ECM from the engine reads the fuel pressure from a fuel pressure sensor. It then closes the loop by telling the fuel pressure control module to speed up or slow down the pump to maintain a specific pressure. The pressure needs to be between 65 and 72 psi. That's kind of the range it operates in. And that feeds the high pressure pump on the motor, which is mechanical. So some people say you got to run the factory system. Others, not so much. The fellow I'm dealing with is Mitch over at Swap Time. And he supplies a lot of the harness pieces and parts that I needed and things. And I think he knows what he's doing. He's done both ways. He said I've done it with the factory and with the non-factory method. I'm going with the non-factory method. I was looking into putting a pump in the tank, so I pulled the pickup out of the tank and realized there were rubber lines between the tank and the hard lines that all were going to have to be replaced, so I had to drop the tank out. That meant dropping the entire rear suspension out of the car. When I got the tank out, I said, this thing is heavy. So I weighed it, and I'll show you a picture in the corner. And that whole mess is 42 pounds, and that's empty. That's a lot of extra weight just to haul around my gas. And I don't even need, nowhere I'm going to need that kind of gas volume. 5 gallons is more than enough for rallycross. My Porsche runs only 2.5 gallons. But bigger engine, bigger car, 5 gallons is enough to run pretty much the whole day. So hauling around an extra 10, 15 gallons, forget it. I'm not going to do that. So I decided to replace the tank. So in replacing the tank, I'm getting a 5 gallon like this right here. And this has a foam inside, and that is 5 gallons. And it only weighs 8 pounds. What a difference. That's going to save a lot. So I decided that's the route I'm going to go. However, that means I'm not running an in-tank pump. I'm running an external pump. Now, instead of running the factory system, Mitch said, no problem, you can run an external with an external regulator. And that's what I'm doing. So I'm going to be coming out of the tank to my pump, a couple of filters, and then go up to a regulator up front. But you still have to have the fuel pressure sensor, and that's going to be located between the regulator and the high pressure pump on the engine. It has to read that pressure all the time. So I will have a return line where the factory system, because it's varying the speed of the pump, does not have a return line. I will have a return line back to the tank. And that's how I'm going to make that work. So let me give you a look inside for mounting here. Just one moment. If you know fuel cells, you know that they have a sump on the bottom like that. It tapers back. Drag racers love that. As you accelerate, all the fuel's at the lower back. That's great. The problem is that usually has to stick through the floor in the bottom of the car. And then you run your pump and your filters all under the floor. Well, I really don't want to do that in a rallycross car because things get muddy, dirty, nasty, and boy, it's a mess to clean up. And I don't want to have to work with that under there. So my intention is to keep it all in the car. I'll put a firewall between the back seat and this, so this will be isolated. But I'm going to go ahead and run my system in the car and run my AN lines up to the front. So I am running AN lines and everything. You got straps to hold the tank down. That's all great. The problem is bolting it down in this well here and trying to hold it level and deal with this sump. So my basic first idea is I've got to come up with something to mount it on down here that gives me room for the sump underneath. And that means I need to space it up about 1.5 inches and mount it on some surface. All of this down here is all different levels of in, out, and all around. So I've got to come up with a flat mounting surface. First idea is just to make some aluminum channels, run them front to back, and mount on that, mount those to the floor. The problem with that is if you use channels, they'll want to walk back and forth side to side, and I'll have to run another channel at the front. I can't run it at the back because of the pickups. So what I'm looking to do here is come up with something I can run front to back. Looking through my junk here, I came up with, I've got a nice big piece of this aluminum, 2x2 aluminum tubing, and I've got enough of it. I can cut it in half, bolt it to the floor, and then this will give me my flat surface to mount this on top. It also gives me the drop so I can run my fuel out of the tank and go to my first filter, then my pump, and then to my second filter, and then up to the regulator up front. So the first thing I have to do is figure out the layout here, cut this in half, drill holes and bolt this to the floor, and then bolt the straps to this. And so when I come back, I should have the tank mounted, and then I can get into all the routing of the fuel lines, the AN lines that are going to run everything here. There we go. So on the fuel system up front, I've got my regulator here. This will be set to 65 to 72 pounds on my gauge. The input comes in from the tank here. The return comes out the bottom and goes back to the tank, and then going to the engine is this piece here, which runs up to this adapter, which connects your quick connect to an AN fitting. And then right here is my fuel pressure sensor. This is absolutely required by the ECU. It has to know what the pressure is, and it calculates that along with the high pressure fuel pump pressure, which has another sensor, to determine how much of a pulse duration to put into the cylinder for each stroke. So it does need to know the pressure. Now in the factory system, what happens here is it reads this pressure into the ECU or the ECM, and then that sends a command signal via CAN bus back to the fuel pressure control module, which actually then controls the fuel pump speed using pulse width modulation. Now, I'm running a straight pump with an external regulator, so I'm not going to control my pressure that way. They don't have a return line. I put one in. That's what that was all about. I ran these lines along the inside of the car on the rocker panel, right where the original lines ran. So I removed the steel lines, and I've got these braided lines running all the way down the side of the car there. So that gets me my pressure up to here, and then this will have to get connected to the ECM wires in this nice little bundle here, which we'll get to shortly. Anyway, that's it for that. So the fuel system is completely mechanically installed. Well, on to the gas pedal. The original gas pedal mounted right up here on a bracket. And this is an electronic gas pedal that has holes down at the bottom and has to get up in here somewhere. And it looks like a really good place for it is right up against that bolt right there, up against the bolt, and then I can push down like so. So what I'm looking at is making a bracket that comes off of the original bolt hole locations there. And then it's going to come down and catch these other two. So a straight plate coming down here and out a little bit with the two holes here and up here. Should be able to bolt it in, thread it or put weld nuts on it and run that down here, and then be able to bolt it on right in that place, about like that. The height of the pedal looks pretty good there, right? Even with my brake pedal and all, I sort of like it. I might get a little bit back, but not much. So that looks like that's the plan. So now to cut a little straight piece of stock, drill some holes in it, and see what it looks like. Okay, so just like that, we got this neat little bracket for the accelerator pedal. Had to put a little bit of a bend right here to get it to pull back from the floor here. It's actually touching, so if I put pressure on it, that's going to actually have nowhere to go, so that'll work just fine. And then this, the pedal, just bolts right up to it there, like that. Give me a second. Now there we go, all installed. Bracket still needs to come back out and get painted, but there we go. We got a nice solid push on that, and we got a good mount there. So this should work just wonderful. So that is mounted for the moment. I'll check to make sure any side pressure doesn't hurt it. I think it should be pretty solid. If I have to, I can put a tab on the other side to help brace it. Can weld something onto it, but that's pretty solid. So I got to be able to reach my switches when I'm in the car with my seat belts on. I learned that the hard way one year. You stall the engine and can't reach the start button, you're in trouble. So the deal is you got to mount this somewhere where it's within arm's reach, sitting in the seat normally, and also not in the way where you're going to accidentally flip the switches up or down or something. And I use these weather-tight plastic boxes, works real good. And simple is always the easiest way to mount things. Don't get carried away. I thought about some fancy mounts, and it just gets complicated, and weight is very important, so you got to make it light. So what I've decided to do here is just take a couple of pieces of aluminum bar stock and strip stock and bolt it to the support here in the center, bolt it to the console, and then this will get bolted through to the bottom, and the wires can come out the bottom on a cord grip, keep the water out of it, and I can reach this easily with everything in here. Easy to see, easy to run, all of that. So very simple, very easy. That's how I'm going to do it. So there you go. I just need to go ahead and drill holes and put bolts in and all that good stuff, and this will be one more thing to check off the list. All right, so now I got these little braces in. They're quite strong, and they don't have to be real big, not much weight, and they're between the frame or the floor and the bar support for the cowl support. That makes them good and sturdy, so they're a stressed member in there. And then this is just simply going to get some holes in the back and bolt it on like that, and lo and behold, I will have my switches mounted. So that's the next step, and there's always another step. Well, there's a lot of goodness. Got my shifter nice and solid. I've got my switch panel where I can reach it from the seat right here. All the switches over to the right. I don't have any problem with that. That's going to be nice. And I got my gas pedal mounted. The seat is mounted. Things are looking good in the car. Mostly good in here. So still got gauges and a few loose ends to tie up. The port to do the OBD port has to be done. A wire to the power, a wire to the brake light switch, and of course my control box here, which has accessories for things like a light out front if I want, a fan in here to blow on my face, defroster, windshield wipers. I'll have to have that on one. So there's a few things you have to have, just basics, and that should be plenty of switches. So, oh, it's a long cry here. Looking much better. The next thing now is to go ahead and get the ECU box mounted and the fuse blocks, and then start running wires between all these wonderful things. And that's going to be very close to getting this thing fired up. Hooray! Well, things really are starting to come together now. I've got a seat to sit in, I've got seat belts, I've got controls. It's starting to get near the end. I figure I'll be able to get it running in another 7 to 10 days. Then it'll have to go to the dyno. So I'm just about to start hooking up the wiring harnesses to each other. But before I do that, there's one more mechanical task that I have to get done. One of the things you find when you're racing is how fast you have to be on the steering wheel. Now, in racing on pavement, they always tell you very small inputs. Don't put too much into it. You rub your tires, you slow down, you cause all kinds of problems with control, and you wear out your tires. Well, on dirt, things are a bit different. If you ever watch WRC, World Rally Championship, those guys are on that wheel, man, those guys are working that wheel back and forth fast and hard about that kind of a movement constantly. And the reason is because when you're on a low grip surface, it takes more input to get the car to do something. Those small inputs that work on pavement, on dirt, the car doesn't even know what you want. You've got to give it a serious input. You don't want to be sawing at it too hard, but you've got to have that quick input. And another thing is, if you have the input, you come out of a turn to grabs, you need to be able to unwind that wheel fast. One of the things that most people do is they go for a quick ratio steering rack, and that helps a lot. However, the difference between a standard and a quick ratio isn't huge. Half a turn of the wheel, maybe 3/4 of a turn from lock to lock. It's not massive. You really want a lot more. One thing I do on all of my rally cars is I put in a little device called a steering quickener. This little guy is a massive help because I don't have to take my hands off the wheel when making pretty much any correction. What it does is it doubles the input to output. So one turn of the steering wheel outputs down here 2 turns into the rack. So it's very fast. Now it does make it harder to steer. If you have power steering, so much the better. It works great. I've got it on cars that have manual steering even. It works incredibly well. So here's the rack out of the car, and here's my doubler. So the thing is, this has to go somewhere in here, somewhere in this area. And the question is where to put it, where to cut, how to fit it. So one of the things I have to keep in mind is that this right here has to be bolted to a bracket, something that won't rotate, okay? So if I put it way down here, I'd have to make a bracket under the dash somewhere to hold on to that. Plus, I've got pedals down here and things, so not the greatest. The other thing is I could put it up here all the way to the end, but I need to hold this. This bracket right here is where you normally want to put it. Say like right there, this would bolt to the same area that this bolts to. However, if I cut this off, I lose this bracket and I have to make a bracket and all, and it's like, well, I'd like to retain this because This has this little lever over here that allows me to lift the wheel up and down like a couple of inches. That's nice when you're getting in and out of the car. I might put a quick release steering wheel adapter on here. They're great for getting in and out of the car, especially people who've got a big belly. But the deal is that I have had those mess up on me, where they stick and the wheel comes off in your hand in the middle of a race, like a national championship. Talk about panic. What happens is dust gets in them from all the dirt and dust we race in, so you got to keep them clean and lubed. So if you race rally, keep that thing in good shape or you'll come off in your hands and you'll be trying to get control of the car again. So bad. Anyway, so what I'm looking at here is saying this here, if it fits in here somewhere, this works real good. In my Porsche, I've got this stub attached directly to the wheel. The bearings in here are plenty strong enough. There's no flex or movement in it. So that's a good thing. So what I'm looking at is placing this like right about here, cutting this tube right here, and then I can slide this inside this tube. It turns out this tube is 1.5 OD with about a 1/16 inch wall, which gives me extra clearance in here. I actually have too much clearance. So what I might do is put a bushing in here, a plastic bushing around this, and slide it in there to center it up. That'll help hold it in place as well. So that gives me a little bit more support. And then come off the top of this right here, bolt here and here. Get rid of this little bracket, and this guy have a plate that crosses over and holds this. So that would handle both. So I'll lose this little bracket, but I'll keep my tilt and slide and all of that. So what I'm looking at is to cut the tube right here, pull the shaft out, check the fit, come back and see if I can pull the shaft down here and install this. Then come back and catch the top end. I don't think I will need this tube up here. It won't serve any real purpose, I don't think. So the next thing now then is to say, okay, let's go ahead and let me go ahead and cut this off, remove this, cut this off, and tear this whole thing apart and start looking at where it's going to fit together. But that looks like the place to put it. Okay? Onward and outward. All right. Let's see if this is running. Yes. All right. So I disassembled the column. I cut the front end off here on this end so that I want to put this in that location. I knew that was where I was going to cut, so I cut that off and I cleaned up the end on the lathe, got that all nice and pretty. And by getting it apart and pressing all the bearings out of it, I can see how it all goes together. This is, as most cars are since the early 70s or late 60s, is a collapsible steering column. And that's so when you get in a wreck and you run into a tree at 80 miles an hour dead center, this here shaft doesn't turn into a spear that tries to kill you. Ask me how I know. Anyway, so this intersection goes inside here, and you see it's got bearings on the outside that it can slide up inside. So in a wreck, this collapses up inside, absorbing the distance in between here, and then this shaft has a double-sided flat that can move in and out like that. It can extend and retract. So what happens is that whole thing collapses, thus shortening the steering column instead of shortening you or putting a hole in you, and that allows this whole thing to absorb the distance between the column and the steering wheel and the firewall. So that's a crash safety feature that's been in for years, and that's how this is put together. So now what I'm going to want to do is figure out if I can get my parts inside here. What I want to do is put this up inside here like that. And it's a very close fit. I can make a little bushing on there maybe to center it up. And then from here to here, I want to make a little bracket that bolts here and bolts here. A little Z bracket. Might make something out of billet aluminum or whatever that bolts these two together, and that's going to hold this so that it doesn't get rotating when I'm trying to turn the wheel. So that's one thing I got to take care of. The other thing is then inside here I've got this coupler that goes on the spline. I've got to get a hold of this shaft. This isn't long enough inside here, and it has stops to keep it from coming all the way out. So I'm going to have to cut this off here, maybe machine it, maybe make a little adapter and weld these together. That's going to go inside here then, and then this guy will get bolted to that. And then on this end, this shaft here is going to hold my steering wheel. Well, this is just a smidge small. I'm going to have to probably make a bushing on that as well so that I can get this other fella on this end, and that'll hold my steering wheel. So that's pretty much what I have to do. So there's a little bit of work involved here. I need to saw this guy off, see what kind of adapter I need to make for that, and start thinking about this little bracket. I do want to maintain my ability to slide up and down in here, so that's another thing. Anyway, that's where I'm at. So, here's how it is so far. In order to fit this inside here, I made a very thin wall sleeve that fits in here nice and snug. That goes in there. That takes care of that problem. That'll center that up real good. In addition, instead of putting it together this way with my bracket, this stays put in the car. This moves up and down. So in order to handle that, when I put this together in here, I'm going to make that little bracket go between these holes here and this right here. I'll drill a hole in this and put a nut on it, or actually I'll probably tap it. So that is going to go to here. Or actually weld the bracket to this, come over here, the two holes, and it'll sit right in there. So that'll take care of that. In order for the shaft to join up to it, I needed to use this little spline adapter on here. It has to sit right there. In order to do that, I made a little sleeve here that fits just inside here and just inside here, two different diameters. Push that together and weld it all the way around. That'll take care of that. Then when I put this in here and I put this in order to get the set screw, I'll have to drill a hole in the bottom here so that I can lock down the set screw that holds this onto this shaft. Then put my little bracket in here and then get to working on the other end. So that'll assemble everything. Grease up the bearing while I got it apart and move on. So this should work real good. Okay? Things are starting to come together. I got the shaft back in here and relocked the seal back in, greased the bearing. Got my hole here, access for my set screw, and got this installed. I got the two together. The problem is the set screw is a little long and it's going to hit the hole on each side when I rotate it like that. So that's a pretty long set screw. I need to get a shorter set screw and lock it in place with some Loctite because I don't believe there's going to be room for a nut in there. Maybe a jam nut. I'll try. Then I got to make the bracket to go from here to here and reassemble everything, and then whatever I want to do on the top end for the steering wheel up top up here, this shaft here. So good progress, decent for today. Looks like I got to stop, get a set screw, and finish all this mess up and make me a bracket. Coming along. So I've got my column going together here. I've got my doubler in on its sleeve. I've got my set screw in, which I Loctited into place because there really isn't room for a nut on top of it, but some good red Loctite does the trick. Now I don't want this to rotate against the steering column. This has to really get locked in place. So to do that, I made a little bracket here that's going to go between there. It's going to bolt to the adapter here, to the quickener, and then I'm going to weld it right here to this little plate that's on the steering column. This moves on up and down. It's on the bottom side. That moves up and down, so this will lock these two together. That'll take care of that. Simple little plate. Just took a piece of flat stock and cut it rectangular, drilled my two holes, drilled two more holes for the rounding of the corners here, and then sawed it out, ground it down a little bit, and good to go. The Z-bend, that's a slick little thing. Real easy to do. Let me show you a little trick. First thing I did is I measured how far above this was from this, and I got a little block that's that thickness between there. And then I set them up in my press. Show you. So the trick here is I simply took the plate that represented the thickness that I wanted it to be, and I got another one the same thickness. I laid it up at an angle in here like that, and then I just pushed the press down. When it starts pressing on these, it'll flatten this side and flatten this side together. These are both the same thickness, so you get a nice little Z-bend when you're done. So I didn't have to use my little jig fixture, and I needed this bend to be pretty close together. The spacing between those determines that distance. And you can block them with C-clamps if you have to the plates here to keep them from moving. But that's an easy way to make a little bend like that, and no muss, no fuss. Piece of cake. All right, weld it up. Really just need both sides. Ready to mask it up and paint it. Just protect the box here. This is all bare metal originally. I sure don't like that. I'm going to give it a little coat of paint. And then this can get reassembled with the slider and installed in the car, and I can get working on the end that holds the steering wheel. That comes next. The next thing I got to do is get the steering wheel the right depth in here, and I've got to weld this stub into this shaft collar that they give me with the spline on it. In order to do that, I need to decide how far back the steering wheel needs to be. So what I did is I cut this off at full length to start with and shoved it in here, and then I put the steering wheel on, and I hang my arm over it like that. And what you want is you want the steering wheel here to be right about in your, right about there in your wrist. And so if your wrist is hanging like that, that's where you want it to be. So it was sticking back about here. So it was too close. So I said I need about 1.5 inches. So all I did was I took the stub, I cut it off 1.5 inches. I set it till it hits the end of the other shaft right away and go, well, where's that? Well, that's where it lands, right there. So now I know that this is where I want it to be. The only thing is there's play in this. It's only about 30 thousandths. It's not enough to make a shim. I would have such thin wall on it, it would cave in. It doesn't do me much good. So to get this centered and square in here when I weld it, what I think I'm going to do is I'll take this and just slice it 4 ways in the saw part way down, and then clamp it with a screw clamp around here and kind of compress it around the shaft. Once it's compressed around the shaft, that'll be damn close to square in there. Weld it, and then go back and weld those up and grind them off. Then I can install this and I'm good to go. The bearing that's holding this right here is about in the same position where the bearing was at the top of the other column, and that's a really good bearing in here, so that'll hold my wheel wonderfully. So this will get me done here as soon as I finish that and weld it up and paint it. This can go back in, the steering wheel goes on, and this project will be done. And I can see how nice and quick it turns the wheels. Very nice. And I still have my up and down here. I can move the whole column up and down like that. That's very important, so I'm getting in and out of the car, that'll be handy. And adjustability, always a good thing. So, onward and outward. All right, so now we have it. Quick turn steering. So now my steering lock to lock is about 1.4 turns. That's lock to lock. Not much at all. So I can get a lot of action out of half a turn of the wheel. This should get me much faster response. So that takes care of that little problem. And I can still raise the column up and down. Got good position. I'm very happy with it. So mark that one off the list.